Hello class, this is Mr. Joseph, and in this video I want to give you some hints about your optimization project that I assigned to you today. So if you're absent today or if you're still a little confused, then watch this video and hopefully it'll give you some hints. So this is the project. You were each given a rectangular piece of poster board, and I just randomly cut them out so they're all of different size, right? But we're going to go ahead and label the length as L and the width as W. So L and W will be different for each of you guys. And you actually want to take a ruler and physically measure your piece of cardboard and write its length and width down on that worksheet. And I would recommend measuring in centimeters because it's easier to work with the decimals. Okay, and the goal of this project is to create a three-dimensional open-top box from this two-dimensional rectangle. And the way that we do that is we cut out congruent squares from each corner. Okay, so the blue lines are kind of where your scissors are going to go, and cut out congruent squares from each corner. And then you can fold the box along these dotted lines, and it kind of creates these little flaps. So you've got your kind of center rectangle here, and then you've got these four flaps that are going to fold up. Let me kind of highlight this guy in red just to kind of show you exactly what shape you'd be working with. Okay. So you got this kind of cross shape. That's again like a base and then four flaps. Okay. Now I'm going to attempt to draw a sort of three-dimensional diagram showing you how this is going to fold up. I did a decent one on the board in class. I'm still kind of getting used to this pen. Whoa. Okay, so that's that rectangular base, and you've got one of the side flaps coming up. Another of the flaps. Let's see. I'll draw it up kind of like this. And then the third flap, which is here, so it would be here. And the fourth flap. Yeah, okay. But, so these are all folding up, right? And that'll give you your three-dimensional box, which I'm actually going to draw on the next page. Okay, so in perspective here, let me actually go back a page. Yeah, okay. So in perspective, what that's going to look like is this. Okay, once it's all folded, it's harder than it looks. Okay, there we go. That's your open top box. But here's the thing: it's not, the project isn't just to make this box. That's relatively easy. That's a small part of your grade. What most of your grade is, what you've been assigned to do, is to give me the box with the maximum volume for your rectangle. So given your rectangle of cardboard, you're cutting out these these square corners, right? Well, there's one specific square you can choose that'll give you a box here with a maximum volume. So that's why it's an optimization project. You're trying to maximize your volume. Okay, so what we want to do is, since the volume here, the thing that we're choosing, the thing that's going to make a difference with the volume is what dimension we choose the square to be that we cut out. So let's give that a name. Let's call it, let me use a different color. Let's call it X. Okay, so the dimension that I'm cutting out of the square here is X. And if it is a square and that's X, then that's X2, and that's X, and that's X. So these are all X. That's the thing that we're controlling here. Okay. So the goal here, if you remember doing these other problems and how it's going to be similar, is to write this, write the volume of this box, which is what we're trying to optimize, as a function of that X. You might be able to figure it out on your own from here. So if you don't want it to be spoiled for you, you can go ahead and do that now.